So in our next question, we've got 2016 and we're asked to consider the reaction scheme. And again, there's a couple of questions in here. Normally what I would do is look at the reaction scheme and see if you can figure out what is going on. Ethene seems to be the major molecule here, and it's up to yourself where you start. I'm going to try and fill in some of the letters. So first of all, we've got ethene and then we have water here. So ethene and water should be going off in your head that this molecule here is something that you have seen before. Now, even if you weren't too sure what this was, you also have a clue in the fact that you have an ester here as well. So what compound can be turned into an ester? And that's what you're trying to think about. Now, at this stage, you should realize that when you remove water from alcohol, you end up with ethene. So going the opposite direction, if you take ethene and you add water to it, you end up with an alcohol. In this particular case, you end up with ethanol. So ethanol minus the water will be ethene. Now, how do we get from ethanol to ethene? And that's what X is. So ethanol to ethene is the first experiment you did. So X, of course, is Al2O3, which is aluminium oxide, which is the white powder that we put in the test tube. That sucks the water out of the alcohol molecule and leaves you with the ethene gas. So that's A and X figured out. We have ester C, which you can figure out as well in a second. Let's go up and have a look at the rest of it. Everything else seems fine. Everything else can be filled in. And before we get on to the ester, let's see if we can answer a couple of questions. So name A and polymer B. So A at this stage, we should know, is going to be ethanol. And then it asks you to work out what polymer B is. So if you have ethene and you're creating a polymer, well then that means you're going to have multiple ethene molecules, which means you're going to have polyethene. Now, polyethene, the ethene's in brackets, is written as polythene, which is your basic plastic bags. Once that's done, we move on to part B, identify substance X. So used in the conversion, so substance X is Al2O3, aluminium oxide. What organic reaction type is involved in this conversion? So we said this already, this is a dehydration reaction. But again, if you really wanted to be specific on this, what I would say here is don't just put in dehydration, put in elimination as well, because you're eliminating the water from an alcohol molecule. Again, all of this is explained very clearly in the previous revision videos. So we've that done now as well. So that's done. That's done. How does the geometry around the carbon atoms change in this conversion? Well, let's have a quick look. So in this one, in part B, we're looking at ethanol. So ethanol, and basically it's turning into ethene gas. So when you're looking at these two compounds, you're asked about the structures. This here is a tetrahedral structure. In other words, there's a 109.5 degree bond angle in here. So this carbon here is tetrahedral. However, in this particular one, this is planar. In other words, everything is in the plane. There is nothing coming, as you're looking at this, there's nothing going out to the back and there's nothing coming forward at the front. So this would be planar. So when it asks what is the change, how does the geometry around the atoms change, it goes from tetrahedral to planar. Part C. What organic reaction type is involved in the conversion of ethane to chloroethane? So we're on part C. So if you're going from ethane and you're surrounded by hydrogens and you're going to chloroethane, chloroethane means that you have replaced a hydrogen with a chlorine. So if you're replacing one atom with another, this is called substitution. Now you don't have to draw all that out, but just some substitution will suffice. Then the next part, describe in detail the mechanism for the reaction between ethane and chlorine in ultraviolet light to produce chloroethane. So here, I'm not going to go through all the mechanism again. It was covered in the previous video. You need to learn the mechanism. You go through your initiation, your two propagations, and then finally your termination and how it ends. Explain the effect of the presence of a little tetraethyl lead, which is PbC2H54, on this conversion. Let me make a small bit more space. So one of the things that tetraethyl lead can do, so I think this is part D. Tetraethyl lead. So the key in tetraethyl lead is this particular part. So tetraethyl lead will supply ethyl free radicals. And you'll be able to see those ethyl free radicals when you draw out the mechanism. So again, an ethyl free radical is something in this shape. So ethyl is C2H5. So you've C2H5 and that's it there. So this is what gives you the ethyl free radical. So tetraethyl lead will produce more of these, and by producing more of these, then that continues the reaction on. So that's the end of that particular question. Oh no, we still have part D. Okay, ester C is formed when A is heated with methanoic acid. So we'll just go back and we'll write in what some of these are, and I'll be back in 1 second. So A is ethanol, just have to go back and find that. And then it says ester C is formed when A is heated with methanoic acid. So if we have it, we have A plus methanoic acid is producing ester C. We know that A is ethanol. So you have ethanol plus the methanoic acid. It's going to produce your ester. Now, your ester is going to be an NO8, and it's this part here that gives the type of NO8. So this is going to be methanoate. And then your ethanol will produce the ethyl part of it. So this is going to be ethyl methanoate. So drawing that out, we've got ethanol, which is C2H5OH. We have our methanoic acid, which is C double bond O, OH. Just going to write the OH like that for the moment. And these two are going to be added together, and then they've got to produce. So if we look at this, what happens is, and this is why I put the H here, so the H and the OH, that's going to form water, H2O. So we can write that over here, plus H2O. And then what's left is this oxygen here, this becomes O negative. And the rest of this molecule, which is essentially C2H5, that joins onto the oxygen. So you now have HC double bond O, O, and then bonded to that, you have a C2H5. And this is where you get your ethyl. And then you have one carbon here, meth, and because it's an ester, and O8 plus water. So you can do that like that as well. As long as you clearly show where everything is coming from, a diagram will perfectly suffice as well. So have we answered all the questions? It says no. It says name C and draw its structure. Okay, we've done that. And then in your drawing, circle the carbonyl group of the ester. Well, that's pretty easy. So circling the carbonyl group of the ester is that bit there. And again, I would write in carbonyl. Then you're going to take you a couple of seconds. And what name is given to the type of reaction that occurs between sodium hydroxide and C? So again, your clue here is sodium hydroxide. This is a base. So when you react a base with an ester, you end up with base hydrolysis. So this is base hydrolysis. But this also has another name, which is saponification. And saponification is the production of soap. So that answers that question. we'll finish that video there, and we will get some more questions over the next day or so. Okay, thank you.